A bad attack of physics envy. Anyone who has witnessed even a single episode of the majestic science documentary, The Big Bang Theory, will readily acknowledge the supreme role played by physics in human intellectual life. Observing the series' protagonists, four sublimely talented young researchers, it is impossible not to recognize the nobility and rigor of the physicists' worldview and the profundity of their spiritual development under the tutelage of this almost miraculous discipline. And yet, the following are three propositions I have developed over the years, which physics cannot, I believe, lightly disregard, but which, I fear, cast a small doubt on physics' preeminence.
1. Physics is easy. We constructed physical laws first because they are obvious by comparison with the far more difficult laws of biology and human nature. 2. Physics is unimportant. It would make no difference at all to anything that matters to most human beings if some of our most basic ideas about the physical universe were quite wrong. 3. Physics is a lousy model for any other science.
All in all, we have wasted enough time and effort on physics worship. 1. Physics is easy. Proposition number 1 is simple and obvious. Is it at all likely that we would have solved the most profound and difficult scientific problems first, leaving only relatively superficial and easy problems to be tidied up later? No. Is the study of physical structures and processes especially challenging by comparison with their chemical, biological, or intelligent counterparts? No. You can do most physics in a lab under nicely controlled conditions, and at least by comparison with, say, evolutionary theory or the study of personality, its findings are pretty easy to replicate and falsify. Building a large hadron collider is hard, but it is as nothing compared to constructing a realistic model of a single human being, let alone a society. Of course, physics results have a pleasing universality. Everything we know about protons or light looks like it's probably true of protons and light everywhere, although the principle of mediocrity is open to challenge, of course. Notwithstanding the complexities of quantum mechanics, it seems pretty easy to identify and demarcate protons and light themselves, at least by comparison with higher-level organic structures, such as species or even particular organisms. On the other hand, outside of natural selection, or very general notions such as adaptation, it is extremely difficult to identify a single biological universal. How much harder is it then to comprehend language or consciousness? It's tempting to argue that physical knowledge had to come first, even though it is the most difficult, because without it, later forms of knowledge are impossible. They need physics to be properly grounded. But this is obviously untrue. Not only are there plenty of cases where theoretical physics changed and no one else noticed, a recent example is detailed below, but biology and the study of human beings have proceeded pretty happily with hardly any input from relativity or quantum mechanics. True, Newton was the inspiration to later thinkers, not least the Enlightenment philosophers. However, it wasn't his physics that they were most affected by. The real inspiration came from his use of highly formalized systems of mathematical models and equations. 2. Physics is unimportant. Proposition number 2 is that it would make little difference to anyone but physicists if our ideas about the physical universe turned out to be quite wrong. This is pretty straightforward too. What would happen if some prestigious lab announced tomorrow that quarks really are made of yogurt and vice versa, as our German cousins presciently intuited? Assuming that these yogurt quarks continue to provide the necessary infrastructure of chemical and biological processes, what difference would it make? To anyone but physicists, none at all. So why should we regard knowledge of physics as especially important? In his masterpiece, Solaris, of which Andrzej Tarkowski made an excellent film, the great Polish sci-fi writer Stanisław Lem speculated that the apparently intelligent ocean that covered his eponymous planet was able to construct increasingly substantial human beings out of neutrinos. The ocean molded the neutrinos into atoms, out of which it then generated the familiar chemical, biological, and psychological structures that are needed to produce the creatures through which it communicated with its human visitors. In other words, the physical building blocks were different, but the architecture remained exactly the same. In that situation, what difference would it make if Lem were right and atoms have a completely different internal structure and composition from the one we believe they have? Beats me. Nor is there any shortage of real-life cases of radical changes to physical theory that made no difference to anyone else. For instance, most of the universe, it turns out, is almost completely invisible to us, except that we are affected by its gravity. At the moment, most cosmologists believe that this barely detectable majority of the universe is made out of so-called dark matter and dark energy. But it might not be. In fact, even as I write this, at least two alternative models, based on the nature of gravity and space-time, are under debate. Has this uncertainty among physicists undermined our understanding of anything else about the rest of the universe? Apparently not. And if it turns out, as some physicists suspect, that dark matter and dark energy are illusions, then physics would have undergone first an epoch-making revolution and then an equally epoch-making counter-revolution, while the rest of us remained completely unaffected. It is not even as though physicists have much of a track record regarding non-physical problems. True, many of the suggestions physicists have made to their neighbors have been very penetrating, most famously, if not very originally, Erwin Schrödinger's "What is life?" But by and large, these insights have been very general, defining, for example, the physical limits of various kinds of activity and event, or possible lower-level mechanisms through which known functions may operate. On the other hand, some of the claims made by physicists, including some as eminent as Erwin Schrödinger, have been not just wrong but scientifically damaging. For example, in his paper On the Age of the Sun's Heat, Lord Kelvin, author of the second law of thermodynamics and the absolute temperature scale later named after him, notoriously condemned Darwin's theory of evolution because the timescales it required exceeded anything that could be supported by known physical processes. The sun, Kelvin argued, simply could not stay warm enough long enough for life on Earth to have evolved to its present level. For Kelvin, this may not have seemed a fundamental difficulty. After all, he believed that
overpoweringly strong proofs of intelligent and benevolent design lie all round us.
But physics' superior status meant that, for biology, his intervention was disastrous.
Darwin was so shaken by the power of Kelvin's analysis and by the authority of his theoretical expertise that, in the last editions of On the Origin of Species, he eliminated all mention of specific timescales.
So science was put back decades by the assumption that if physics said something was impossible, that should be good enough for everyone else. The utterly compelling logic of evolution, driven by the simplest rational deduction and supported by the thorough examination of the most compelling biological facts, were not enough. In short, the authority of physics stymied one of the few contributions to science that exceeded Kelvin's own. On the other hand, the adoration of quantum mechanics is constantly casting its baleful shadow far and wide. After all, it offers such a great excuse for trite and sloppy extrapolations of the idea of uncertainty, such an irresistible enticement to intellectual self-censorship, and such a pall of comfortable pessimism. In short, not only would it not matter much if physical theory were quite wrong about basic physical realities, but sometimes science as a whole would be a lot better off if it trusted less to the alleged pre-eminence of physics and gave a bit more credit to the evidence and logic of individual disciplines. 3. physics is a bad model for science. Finally, physics is a lousy model for other sciences. Its very simplicity makes it accessible by all manner of techniques it would be quite absurd to demand of other sciences. Regarding the traditional formal structure of physical methods, how could one possibly do ethology or ethnology in a laboratory or by the logic of ceteris paribus? Any even moderately clever species is capable of responding to the fact that it is being studied, often leading not only to the modification and disruption of the very activity the scientist is trying to understand, but to the organism actively deceiving the observer. Conversely, what did the great mass of traditional psychological experimentation that strove to mimic physics contribute to our understanding of human nature? Admittedly, this mimicry was based on a very superficial interpretation of physical method, but in most cases it would still be kind to say, not very much. Indeed, it would be truer to say that much of it sent our self-knowledge backwards. As one must expect of methods that trivialize the subtleties of human experience and action, the results was largely trivia. Of course, I simplify, perhaps even trivialize a little myself. But when was there a time when physics was not aggrandized, the opposite but equal sin? Ernest Rutherford, a wonderful experimentalist, was not alone in believing that.
In science there is only physics, all the rest is stamp collecting.
But then he was also a member of the Kelvin school of razor-sharp analysis. For example,
the energy produced by the atom is a very poor kind of thing, and anyone who expects a source of power from the transformation of these atoms is talking moonshine.
With that kind of track record within physics, what on earth would compel me to listen to his opinions on anything else? Conclusion. What is wrong with physics, then? Nothing really, as far as it goes. But it only goes as far as the limits of physical structures and processes, beyond which its opinions are of no more value than a sociologist's views on steroid chemistry. Leaving aside the perfectly valid generalities and constraints proposed by Schrödinger and other physicists, physics makes no useful predictions about higher sciences. What is more, it lacks the ability to do so not because they are beneath physics, no better than stamp collecting, or because organic life or intelligence are mysteriously beyond science. They are simply qualitatively different from the physical. A quite different logic is at work in tulips and sperm whales and human beings from that which applies to quanta and quasars. This is why physicists' dreams of a grand unification theory or a theory of everything are so misplaced, not to say grotesquely pretentious. Quantum and relativistic physics unified? Hooray! But what will the resulting masterpiece have to say about income tax?
To boost the British economy, I'd tax all foreigners living abroad.
Or the poetry of Verlaine? Nothing whatsoever. So are taxes and poetry illusions? Only if the science of physics is too. After all, the ability to formulate or understand, say, the theory of quantum chromodynamics, QCD, has much more in common with the ability to write literature or administer a bureaucracy than it has with the strong nuclear force QCD describes. Not that supraphysical entities are not also physical. But physics worship tends inevitably to the invariably false nothing but ism. A living thing can be broken into its physical constituents, but then it is both literally and metaphorically dead. Conversely, there is nothing at the physical level that explains what it is that makes something come alive. This is not a plea for mysticism. One can't deduce a school of architecture from a pile of bricks either. In short, far from ostentatiously imagining that they could ever come up with a theory of everything, physicists would do better to accept that their best hope is for a theory of quite a few quite interesting things, but no contribution whatsoever to quite a lot else. Of course, this isn't a problem of physics alone. Deference to evolutionary biology and neuroscience have had a similarly detrimental effect on the development of the human sciences, where the specifics of what human beings actually do have been filtered through a self-censoring sense of obligation to fit in with biological concepts and models. But the methods of science are defined not by mimicry of physics or biology or any other a priori model, but by careful consideration of the goals it seeks to achieve, that is, objective knowledge of a specific domain of reality. They cannot be defined a priori by what happens to have been a useful approach in an easier area of reality. Groveling before the altar of physics or biology really is the worst kind of anti-scientific argument from authority.